Jupiter is the fifth planet from the Sun and the largest in the solar system. If you were to take all of the other planets in the solar system and smash them together into one big ball, Jupiter would still be more than twice as massive as that ball. Jupiter is named after the king of the ancient Roman gods, with the Greek equivalent being Zeus. The word for anything related to Jupiter is Jovian, like saying the Jovian atmosphere or the Jovian moons. Being the solar system's biggest planet, Jupiter is among the brightest objects in the night sky. It's beat out only by the Moon, Venus, and sometimes Mars. It's also the oldest planet, having formed from gas and dust that was left over from the Sun's creation about 4.5 billion years ago. You may have heard Jupiter referred to as a failed star, but that's not exactly true. Sure, Jupiter is made up of a lot of the same materials as a star. It's way too small to be one, though. The planet would need to be about 80 times its current size to ignite and become a star. He's not a failed star. He didn't even try, and he didn't even come close. As the most massive body after the Sun, Jupiter has helped to shape the history and future of the solar system. According to a scenario called the NICE model, Jupiter may be responsible for flinging Uranus, Neptune, and smaller objects like asteroids away from the Sun. In the present day, Jupiter helps keep asteroids and comets from bombarding the inner planets. Its strong gravity can suck in and absorb smaller objects, or just kick them out of the solar system entirely. But that same gravity can also accelerate objects towards the inner planets, so whether or not Jupiter wants to protect us depends on how he feels on any given day. Let's fly in and take a closer look at the solar system's biggest planet. Jupiter orbits an average of 484 million miles away from the Sun. This distance can vary, though, because Jupiter's orbit is not a perfect circle. At perihelion, or its closest point to the Sun, it's about 460 million miles away. At aphelion, or its furthest point, it's instead 507 million miles from the Sun. Jupiter has the shortest day in the solar system at only around 10 hours. This thing is spinning incredibly fast. Its year is close to around 12 Earth years. The planet's equator is tilted by about 3 degrees with respect to the plane of its orbit around the Sun. This means it spins nearly upright and doesn't experience any extreme seasons like Earth or Mars do. Jupiter's rotation is a little bit complicated, though. 3 different rotation periods have been established for Jupiter, all of them within a few minutes of each other. This is because Jupiter has no solid surface, and the gas that composes it rotates at different rates. System 1 of Jupiter's rotation lasts about 9 hours, 50 minutes, and 30 seconds. It's the speed of rotation at and around the planet's equator. System 2 applies to regions further away from the equator, and it lasts about 9 hours, 55 minutes, and 41 seconds. Finally, there's System 3, which is considered the true rotation period of Jupiter. It lasts 9 hours, 55 minutes, and 29 seconds. It's the rotation period of Jupiter's magnetic field, and it also applies to the interior region where this magnetic field is generated. So yeah, Jupiter's rotation is a little bit wacky. All the rotation periods can be rounded up to 10 hours though, so the general estimate still applies. As a gas giant, Jupiter lacks a solid surface like what the 4 terrestrial planets have. It's unknown if it has a solid inner core, but if it does, that core is probably about the size of Earth. Jupiter's radius is around 43,440 miles, which makes it 11 times wider than Earth. Its composition is pretty similar to the Sun. It's mostly made of hydrogen and helium, and its average density isn't much more than that of water. Deep into Jupiter's atmosphere, the temperature and pressure increase to compress hydrogen into a liquid. This gives Jupiter the largest ocean in the solar system, and it's all made out of hydrogen instead of water. Even further in, at depths about halfway to Jupiter's center, the pressure increases so much that electrons are squeezed off of hydrogen atoms, which makes hydrogen sort of electrically conductive like metal. This is called metallic hydrogen. This region of metallic hydrogen may be the source of Jupiter's magnetic field. The planet's fast rotation is thought to drive electrical currents in this region, thus producing the magnetic field. Jupiter probably has some kind of internal heat source because it emits more heat than it receives from the Sun. This source of heat might be leftover energy from compression when Jupiter formed. Like most of the planet, Jupiter's atmosphere is made up mostly of hydrogen and helium. One of the planet's most notable features are its stripes and swirls, which are cold and windy clouds of ammonia and water. These stripes on Jupiter have different names. The dark orange stripes are belts, and the lighter bands are called zones. They flow east and west in opposite directions. Jupiter's fast rotation creates strong jet streams that separate the clouds into these belts and zones. The vivid colors in these thick bands may be plumes of sulfur and phosphorus ice-containing gases rising up from the planet's warm interior. Jupiter is likely to have 3 distinct cloud layers that altogether span about 44 miles. The top cloud is probably made of ammonia ice. The middle layer is likely made of ammonium hydrosulfide crystals, and the lower or innermost layer may be made of water ice and vapor. With no solid surface to slow them down, spots on Jupiter can persist for years. Changes in the cloud systems can occur over just a few hours, but there seems to be an underlying pattern of latitudinal currents that has maintained its stability for decades. Some of the winds on Jupiter can reach up to 335 miles per hour at the equator. Jupiter features cyclones that are warmer on the top with lower atmospheric densities and colder on the bottom with higher atmospheric densities. These cyclones also have an arch nemesis in the form of anticyclones, which rotate in the opposite direction and have opposite temperatures, colder at the top, warmer at the bottom. Some of these storms extend as far as 60 miles below the cloud tops. Jupiter also has cyclones at its poles. These giant cyclonic storms are arranged in polygonal patterns. 8 cyclones form an octagon in the north, and 5 form a pentagon in the south. These polar cyclones are extremely resilient and seem to just remain in the same location. Jupiter's atmosphere is pretty fascinating. It's got a whole lot of stuff going on, like wind and storms, and even more storms. Speaking of storms, it's time to talk about Jupiter's Great Red Spot is a storm bigger than Earth that has raged for hundreds of years. It has been continuously observed since 1878, and it may be the same storm that was observed from 1665 to 1713. The color of the storm has been attributed to the presence of complex organic molecules, red phosphorus, or even a sulfur compound. The Great Red Spot has lived an awfully long time, especially compared to other storms on Jupiter, which can last mere days. The storm had a maximum extent of about 30,000 miles in the late 19th century. Since then, its size has shrunk. Since 2012, it's become more circular instead of oval-shaped, and its current size is about 10,000 miles. The height and size of this storm mean that the concentration of atmospheric mass within could be detectable by instruments studying Jupiter's gravity field. 2 close flybys from the Juno spacecraft provided an opportunity to search for the storm's gravity signature and complement other findings on its depth. With this gravity data, the Juno team estimated that the Great Red Spot extends about 300 miles below the cloud tops. Strangely, the rotation period of the Great Red Spot doesn't match any of the 3 systems of Jupiter's rotation. It has shown variability that hasn't been correlated with other phenomena on the planet. Observations from the Voyager mission revealed that the material within the spot rotates once about every 7 days. This makes it an anticyclone. The Great Red Spot is heating Jupiter's upper atmosphere and making it hundreds of degrees hotter than it would be from solar heating alone. Although we can pretty obviously see the very top of the storm, the lower extension has never been observed. The Great Red Spot will probably disappear someday. No storm can last forever, and it's already been shrinking. I wonder what it would be like to look at Jupiter and just see no Great Red Spot. That would be a little unusual. Jupiter's magnetosphere is the region of space that is dominated by the planet's magnetic field. It balloons 600,000 to 2 million miles towards the sun, and in the opposite direction, it tapers off into a tail that extends 600 million miles from Jupiter. Jupiter's enormous magnetic field is many, many times more powerful than Earth's. It rotates with the planet and sweeps up particles with an electric charge. Near the planet, the magnetic field traps charged particles and accelerates them to very high energies. This creates intense radiation that bombards Jupiter's inner moons and can damage spacecraft. If you were to try to fly to Jupiter, there's a good chance you would die from the radiation before ever reaching the planet. Like Earth's magnetic field, Jupiter's causes auroras. Because of the strength of the magnetic field, these auroras are some of the most spectacular in the solar system. Jupiter's magnetic field is the strongest of any planet in the solar system. The magnetosphere is so large that if it were visible from Earth, it would look larger than the moon. And that says a lot because Jupiter itself kind of just looks like a really big and bright star in the night sky. The magnetic field is the source of intense bursts of radio noise, some of which occasionally radiate more energy than the sun. These bursts of radio noise were among the first pieces of evidence for the existence of Jupiter's magnetic field. Jupiter has a lot of moons, and by that I mean 95 officially recognized moons. The specific number I came across differed between the sources I read. Some said 79, others said the number was in the 80s, but that's probably just because some of these were written before more moons were discovered. The point is, Jupiter has a lot of moons. Most of Jupiter's moons are named for mythological characters or figures that are associated with the Roman god Jupiter or his Greek equivalent Zeus. The four largest moons, Io, Europa, Ganymede, and Callisto, were first observed in 1610 by Galileo Galilei. These are now known as the Galilean satellites, and they were the first bodies observed orbiting an object other than Earth. The discovery supported the Copernican view that Earth is not the center of the universe. These four largest moons are interesting worlds in their own right. Io is the most volcanically active body in the solar system. Ganymede is the solar system's largest moon, and it's even bigger than the planet Mercury. Callisto's very few small craters might indicate a slight degree of current surface activity. And Europa's frozen crust could contain a liquid water ocean with the ingredients for life. The fifth known moon, Amalthea, was the last one to be discovered by direct observation. All subsequent moons of Jupiter have been found in photographs or electronic images taken of the planet. The orbits of the inner 8 moons are almost circular and lie within the plane of Jupiter's equator. Because of these moons' low eccentricities and inclinations, they are known as regular moons. However, the orbits of dozens of moons beyond Callisto have higher eccentricities and inclinations. These are known as irregular moons. 2 of the innermost moons, Metis and Adrastea, are associated with Jupiter's ring system. They act as sources of fine particles as well as gravitationally controlling shepherds. They keep the particles of the rings in place. Amalthea and Phoebe also contribute to the ring system by producing very tenuous gossamer rings slightly further from Jupiter. The regular moons are thought to originate from a disk of gas and dust that once existed around Jupiter. This disk then just condensed into the regular moons. The irregular moons are thought to have come from captured asteroids, some of which may have broken up as they were captured or were shattered apart by impacts from other objects. Jupiter already has a lot of known moons, but there could still be smaller ones closer to the planet that haven't been discovered, and there are almost certainly more irregular moons even farther out. The existence of Jupiter's rings was first hinted at in 1974 by the Pioneer 10 spacecraft when it detected a sudden decrease in the presence of charged particles inside the orbit of Metis, which is Jupiter's innermost moon. The faint ring system was later definitively discovered by the Voyager 1 spacecraft in 1979. These rings came as a surprise because they're so faint that they cannot be seen from Earth. The rings are composed of small, dark particles, and they're difficult to see except when backlit by the sun. Data from the Galileo spacecraft indicate the ring system might be formed from dust that's kicked up when interplanetary meteoroids crash into the innermost moons. The ring system consists of 4 principal components. From farthest to closest to Jupiter, there's the outer gossamer ring, the inner gossamer ring, the main ring, and the halo. The outer gossamer ring fades into invisibility beyond the orbit of the moon Thebe. The inner gossamer ring extends from the edge of the outer one to the orbit of Amalthea. The main ring extends inwards from the orbits of Adrastea and Metis to its inner edge at around 76,000 miles from Jupiter. Finally, the toroidal or donut-shaped halo extends from the edge of the main ring to around 57,000 miles from Jupiter. This halo is caused by electromagnetic forces pushing particles away from the plane of the main ring. Since Jupiter is bigger than Saturn, you might think it should have much bigger rings than it. And you wouldn't be the only one. Scientists have looked into this. And the answer? Jupiter's largest moons are the culprit behind the lack of a stunning ring system. The Galilean moons would quickly destroy any large rings that might form. Their gravity could toss pieces of rings out of Jupiter's orbit or change the orbit of those pieces slightly so that they just crash into the moons. The presence of the Galilean moons also means it's unlikely that Jupiter ever had a spectacular ring system like Saturn's. And that's Jupiter. I hope you enjoyed this little exploration of the solar system's biggest planet. I personally think Jupiter is the prettiest planet in the solar system. Its colorful stripes are super nice, and the polar regions are just beautiful. I'll be making a video all about the moons of Jupiter pretty soon, so if you're interested in that, feel free to stick around. I also have other solar system spotlight videos that you might want to watch. I have one on the Sun, Mercury, Venus, Earth, the Moon, Mars, and both of Mars's moons. Thanks for watching, like and subscribe if you enjoyed, and have a good day!